Hopefully you've read the lesson or watched the lesson on reading the z-table. If not, please go back and do that. You'll need that information to be able to follow what I'm doing right here. What we're going to do today is we're going to use the z-table to find some areas, some probabilities. They're interchangeable, areas and probabilities. Okay, so what I'm going to do here is, if you look, the way I've worded this question, what is the area under the standard normal curve, the z-table, to the left of this number right here, negative 1.43. Now, what I'm going to do is draw a picture of this to see what's going on. Well, as we know, 0 is in the center, so negative 1.43 will be over here to the left. And we want to the left of that number, because that gives me this shaded area right here. Now, if you go to the z-table and you look up negative 1.43, you should get the following value. 0.764. Now, if you recall from the z-table how you read it, the z-table always gives you the value to the left of the number you're looking up. So in this case, what is the area to the left of negative 1.43? Well, it's going to be exactly the same area that the z-table gives you. Exactly the same area. When you have an area to the left, that area is exactly the number off the z-table. Now, if we look at this situation here, now we're looking to the right of a value. Well, I'm going to draw a picture of this to see what's going on. I highly encourage you to draw a picture so that you don't get confused, make mistakes, and miss points. Okay, again, we know that 0 is the very center of this. 1.68 is to the right of center, and this wants the area to the right of 1.68. So that's the area to the right of 1.68. Now, how do we get that? Well, if we look up on the table, we will get the following number. 0.9535. Okay, hopefully you can see that okay. It's in red. Now, the reason I put it in red is because it's not our answer. Our answer will be in black. That's what we want. So, what is that number, 0.9535? Well, that's the number the z-table gives us. And as we know, the z-table always gives you the number to the left of what we look up. So we look up 1.68. It gives us the area of the red. The red area is a 0.9535 I have here. Okay, so if that's that area, how do we find the black area? Well, if you remember, the standard normal curve is a probability distribution. That means that all the area under the curve adds up to 1. So this red number plus the black number equals, the red area plus the black area equals 1. So if I take 1 minus the red area, that will give me the black area. 0.0465. Now, we got another situation. In between. Okay, in between, I've got a negative 2.33. It's a negative number, so it's on the left. And a positive number, which is to the right of 0.75. And we want the area in between. Now, how are we going to get this area in between? Well, the 0.75, if you look it up, and I have that number available to me. I think. Yes. If I look the 0.75 up, I get 0.7734. What area is 0.7734? It's everything to the left of 0.75. Now, notice that includes the area to the left of negative 2.33. Well, if you look at negative 2.33, I get, and this in black, so I'm going to mark this in black, 0.0099, and this is the area in black. So what mathematics can I do? What geometry can I do so that I have the area between negative 2.33 and 0.75? Well, if I take the red area, which is all of this, and then I subtract the black area, look what I'm left with. Exactly what I was asked to do. So I do the subtraction here. 5, 3, 6, 7. You get 7, 6, 3, 5. Now, one thing I want to point out, whenever you work in these problems with a normal curve or any normal distribution, you're going to have three cases: less than, greater than, and in between. This is standard: a less than, greater than, and in between. Okay, let me pause for a moment, and I'll put a few more up here for us to look at. Okay, I have some answers up here. Hopefully you did these on your own and you did not rely, just skip forward and wanted to look at my answer. Okay, let's look at the first one over here. To the left of negative 1.24, here I drew the standard normal curve again. I marked negative 1.24 and shaded in the area. That is represented by that. I looked it up on the z-table. I got 0.1075. To the right of 1.48, again, I drew a standard normal curve. I put 1.48 on this curve and shaded in the area I'm interested in. Now, in this case, it's a right-tailed problem. Remember this vocabulary I'm using. And when you have a right-tailed problem, you're going to take 1 minus the area to the left, which is what the z-table gives you. And you're left with 0.0694. Now, between, you look at 2. The z-table gives you 0.9772. You look up negative 2, which is this area right here, 0.0228. You take the bigger area, subtract off the smaller area, 0.9544. Now, that is how you read. That is one way to read the standard normal curve. I will show you another. This is reading it as area under the curve. You can also read this or view it as probabilities, and that'll be in the next video.